Hello student, in this lecture I will discuss elaborately the main parts of IR spectrometer. Okay, so the main parts of IR spectrometer are radiation source, second is sample cells and sampling of substances, third is monochromator, fourth is detector, and last one is recorder. Okay, so there are 5 main parts of IR spectrometer. Okay, now let's see the first part, that is radiation source. So first radiation source which have we use radiation source as infrared sources. So IR instrument require a source of radiant energy which emit IR radiation which must be sufficient intensity, continuous and stable. Okay, so IR instrument require a source of radiant energy which emit IR radiation which must be sufficient intensity, continuous and stable. So sources, we can use different type of sources of IR radiation. Okay, so first is we can use globar as a IR radiation sources, as a sources of IR radiation. Okay, we can use globar as a source of IR radiation. Okay, so in globar, material used is silicon carbide. Length of cylinder is 50 millimeter and diameter is 5 millimeter. Okay, so in globar sources, material used is silicon carbide. Length of cylinder is 50 millimeter and diameter is 5 millimeter. It has positive temperature coefficient of electrical resistance. At low temperature, they provide low resistance to flow current, and as cylinder gets heated, resistance increases, allowing conduction of current. Okay, so at low temperature they provide low resistance to flow current, and as cylinder gets heated, resistance increases, allowing conduction of current. To avoid excessive heating, water cooling is necessary, and at high temperature source emits IR radiation. Okay, so globar is a rod of silicon carbide. Globar is a rod of silicon carbide. That means in globar sources, material used is silicon carbide. So rod of silicon carbide is used, and this is heated up to 1300 degrees centigrade, and it produces radiant energy from 1 to 40 micron. Okay, now see the second source, this Nernst glower. We can use this Nernst glower as IR radiation sources. Okay, so there are various types of source. One type is globar, another one is Nernst glower. Okay, so here the rod material is zirconium and yttrium. Okay, and this is heated up to 1500 degrees centigrade, and it emits radiation between 0.4 to 20 micron. Okay, so Nernst glower consists of cylinder of rare earth oxides formed into cylinder of diameter 1 to 2 millimeter length, approximately 20 millimeter. Okay, platinum disc are attached at the ends of cylinder to permit electrical connection. They are heated to a temperature of 1200 to 2200 Kelvin, where IR radiation are emitted. Rare earth metals have large negative temperature coefficient of electrical resistance. A negative temperature coefficient occurs when a physical property such as thermal conductivity or electrical resistivity of a material lowers with increasing temperature, typically in a defined temperature range. Okay. So rare earth metals have large negative temperature coefficient of electrical resistance. And in Nernst Glower, temperature is inversely related to resistance. At low temperature, they provide high resistance to flow current, and as cylinder gets heated, resistance gets reduced, allowing conduction of current. Okay, so at low temperature, they provide high resistance to flow current, and as cylinder gets heated, resistance gets reduced, allowing conduction of current. If large amount of current flows through cylinder, it can destroy the source. Okay, so if large amount of current flows through cylinder, it can destroy the source. To avoid this, source circuit should be designed to limit the current. Okay. Now, there is another source which we can use as a IR sources. So third source is incandescence wire source, that means nichrome wire. So in nichrome wire, cylinder is tightly wound by spiral wire of nichrome or rhodium. Okay. Here I have given the figure also. So cylinder of these sources is tightly wound by spiral wire of nichrome and rhodium, and it is electrically heated at 1100 Kelvin. Okay. Fourth is mercury arc. Okay. So quartz, for mercury arc, quartz jacketed tube, Hg vapors, electricity, quartz for mercury arc, quartz jacketed tube, mercury vapors, electricity passed through mercury vapor provides radiation. Okay, so this is fourth source which we can use as a IR radiation sources. Okay. Third is tungsten, next is tungsten filament. Okay, so tungsten filament we can use as IR radiation sources, and last one is carbon dioxide laser source. So carbon dioxide laser source we can use as a IR sources. So here in this 4 to 5 slide, I have described the sources of IR radiation. So first I have discussed the global sources, then Nernst Glower source, next is nichrome wire, mercury arc, tungsten filament, carbon dioxide laser. So these are the sources which we can use as a IR radiation sources. Okay. Now I will discuss about Now I will discuss about sample cell and sampling of substances. Okay. The sample for IR spectroscopy, sample may be gas, it may be liquid, or it may be solid. So for if the sample is gas, then it forms as gas cell, and if sample is liquid, then it forms as a thin film. For solid, it forms as caviar disc, moles, or deposited film. Okay. So see gases, if we use sample as a gases. So infrared transparent windows allow the cell to be mounted directly. Internal mirror are used which permit the beam to be reflected several times through the sample to increase the sensitivity. In vapor phase rotational changes in molecule occur freely, and these low frequency processes can modulate the higher energy vibration bands. Okay. So gases are infrared transparent windows gaseous cells are like this. Infrared transparent windows allow the cell to be mounted directly. Okay. Internal mirrors are used which permit the beam to be reflected several times through the sample to increase the sensitivity. In vapor, phase rotational changes in molecule occur freely, and these low frequency processes can modulate the higher energy vibrational bands. Now see the liquid. If our sample is liquid. So liquid sample consists of a sampling liquid as a thin film squeezed between two infrared transparent windows like NaCl flats. Okay, so liquid sample consists of a sampling liquid as a thin film squeezed between two infrared transparent windows like NaCl flats. The salt plates, NaCl is salt, so the salt plates or rock salt salt plates or rock salt flats must be optically polished and cleaned. So liquid sample consists of a sampling liquid as a thin film squeezed between two infrared transparent windows like NaCl flats. The salt plates or rock salt flats must be optically polished and cleaned immediately after use. Toluenes, chloroform, etc. are used to clean them, and they should be dry and handled only by their edges. Okay, so this is our liquid sample, how liquid sample consists. And okay, now the thickness of the film can be adjusted by varying pressure used to squeeze the flats together. Okay, so thickness may be 0.01 to 0.1 millimeter, and it consists of two windows of pressed salt. It consists of two windows of pressed salt sealed and separated by thin gaskets of Teflon, copper or lead that have been wetted with mercury. The windows are usually made of sodium chloride, potassium chloride or cesium bromide. Okay. There are two cells, first cell containing sample and second one containing pure solvent placed in reference beam. By the reference beam, solvent absorption are cancelled out and spectrum recorded is that of solute alone. Okay. Now see the solid. If our sample is solid, so in solid there are three types. One KBr disc, second is moles, and third is deposited film. Okay, so now I will discuss KBr disc. So KBr disc is prepared by grinding the sample with KBr and compressing the whole into a transparent water or disc. KBr must be dry, and hence grinding is carried out under infrared lamp to avoid condensation of atmospheric moisture, which gives rise to broad absorption. Grinding is done in a mortar pestle or commercial ball mills. Poorly ground mixtures lead to discs that scatter light, then they transmit. Particle size of 2 micrometer must be achieved to avoid scattering. Compression of cohesive disc require high pressure. Special die are used from which air can be evacuated by hydraulic compression. Discs thus formed are easy to handle. Next solid sample is moulds. Pastes prepared by grinding the sample with a drop of oil. The mold is the squeezed between transparent windows as for liquid sample. Molding agent should ideally be infrared transparent, but this is never true. Liquid paraffin is used to prepare liquid paraffin molds, which is transparent over a wide range in IR spectrum. Next, depository film means solid films. Solid films can be deposited onto NaCl plates by allowing a solution in a volatile solvent to evaporate drop by drop on the surface of the flat. So, solid films can be deposited onto NaCl plates by allowing a solution in a volatile solvent to evaporate drop by drop on the surface of the flat. Polymers and various waxy or fatty materials often give excellent spectra in this way. Okay, so these are the samples which we use in IR spectroscopy. Okay.